Today, we're going to dig into a question that's, well, literally right under our feet. Just how thick is the Earth's crust? And trust me, the answer is a lot more surprising than you might think.
You know, when you're standing outside, the ground feels so solid, right? It feels strong, maybe even endless, like it just goes on forever. But what if I told you that entire feeling is basically an illusion?
Yeah, really. Compared to the rest of the planet, the solid ground we all live on is incredibly, shockingly thin. And it turns out that thinness is the key to understanding, well, pretty much everything about our world.
So, let's peel back that layer and get a clearer picture of this deceptive surface we call home, the Earth's crust.
The crust is everything we see and interact with, right? It's all the continents, the vast ocean floors, every mountain, every valley. But even though it feels so massive to us, it's really just this fragile shell protecting us from the immense fiery engine that's churning away down below.
And here's the first big clue in all this. That shell isn't just one solid piece. The ground isn't the same everywhere. Nope. It actually comes in two very distinct types, and understanding this difference is absolutely critical.
Just look at the contrast here. On one side, you've got the continental crust. That's what makes up our continents. It's much thicker, but, and this is the weird part, it's actually less dense. Then you have the oceanic crust, which is the floor of all our oceans. It's way, way thinner, but it's also heavier and denser. This little difference is going to be incredibly important in just a minute.
All right, so we know there are two types, but how thick are we actually talking about here? It's time to put some numbers to this.
First up, let's look at the ground beneath the continents. The land we're all living on right now.
So on average, continental crust is about 30 to 50 kilometers thick. To put that in perspective, that's roughly 20 to 30 miles deep. And under major mountain ranges, like the Himalayas, it can get even thicker, pushing down as far as 70 kilometers. That's a lot of rock.
Okay, now let's compare that to the crust lying at the bottom of our oceans. And you might want to brace yourself for this one. The oceanic crust is, on average, only 5 to 10 kilometers thick. That's it. We're talking just 3 to 6 miles. It's a massive difference. In some places, the continental crust is literally 10 times thicker than the oceanic crust.
I mean, just look at that difference side by side. This isn't just a small variation. It's a huge, fundamental distinction. This massive gap in thickness is one of the most important features of our planet's surface, and it shapes everything, from how high mountains can get to how deep the oceans are.
Now, I know those numbers are big, and they can be kind of hard to wrap your head around. So to really grasp just how thin the crust is, let's use an analogy. Imagine we could shrink the entire Earth down to something we could hold in our hand.
Just picture it for a second. The entire planet, all the oceans, mountains, continents, from the surface right down to its super hot core, is now the size of a regular apple you'd find at the grocery store.
That's it. That's all it is. Everything we know, everything we've ever built, every single place we have ever been, exists on a layer that is proportionally as thin as the skin on an apple. The entire rest of the planet lies beneath that incredibly delicate layer.
So you have to wonder, why is the crust so thin, and what does it all mean? Because this isn't just some fun fact. It's the very reason our planet looks and behaves the way it does.
Well, it all goes back to how the Earth was born. In its early days, our planet was just a giant molten ball of rock. Over time, the heaviest materials, like iron, sank down to form the core. Meanwhile, the lighter, less dense stuff floated to the top. As these lighter materials cooled, they hardened into the thin crust we see today, kind of floating on top of the much larger, hotter mantle below. So here's the real takeaway. This thinness isn't just trivia. It explains pretty much every major geological thing that happens on Earth, because the continental crust is less dense, it floats higher on the mantle. That's why we have continents. The way these thin, brittle plates grind against each other is what causes earthquakes, creates volcanoes, and constantly reshapes our world. It's why some places are prone to disasters and others are rich with minerals. It's all because we live on this thin, cracked skin.
So I'll leave you with a final thought to chew on. The next time you look at the world, remember that apple. We're not living on some solid, immovable rock. We live on the incredibly thin, fragile, and dynamic skin of a planet. And, well, that might just change how you see everything.